All right, welcome everyone. We'd like to welcome you to our webinar today, Extending the Lifetime of the Components and Power Transformers, hosted and presented by Amorim Cork Composites. We're really excited for you to join us today. Today in this webinar, we'll have two speakers presenting. First will be myself, Chris Schenck, business developer at Amorim Cork Composites. And along with me today as well is Marta Reinas, Global Technical Manager for Amorim Cork Composites. So we know that in the power industry, there are several large challenges facing the power industry currently. They have a large aging infrastructure, so we have a lot of transformers that are out there in usage that are reaching the end of their life cycle and need to be replaced. We also have new and more stringent environmental regulations that that are causing manufacturers to adjust the type of oils that are being used and other types of energy efficiency ratings that they need to meet. We also know that there is a tremendous amount of cost pressure from the utility companies that purchase the power transformers and maintain the grids. There's a large increase of demand for energy from the consumer base. And at the same time, there's a large increase for that energy to come from renewable sources. So those type of transformers are slightly different than the current ones that are in use. So all of these things lead to transformer manufacturers needing to get as much as they can out of their units. And one of the ways they can do that is to extend the maintenance periods and extend their time having the down cycles. So that's where noise and vibration control come into playing a part in helping in this application. And so why would a Cork company want to talk about vibration control? Well, the reason is that just putting some rubber in the situation can actually cause more problems than you're trying to isolate. If you don't understand the natural frequency of the material, or if you're not sure what the disturbing frequency of the unit is, you can actually add to the problem and create more problems than you're trying to solve. So one thing we know and we need to understand to properly address this type of application is to understand the disturbing frequency. The disturbing frequency that happens in transformers is typically the double of the electrical frequency that the unit is operating at. So typically in North America, we operate in 60 hertz frequency, and so then you would get increments of 60 hertz, so 120, 240, 360, and the same goes with the 50 hertz that's used in some other parts of the world where it would be the double again, 100, 200, and 300. So we know then where the source of the noise comes from. We know the disturbing frequency. So how do you approach trying to limit and to get rid of some of that noise and some of that vibration? Well, there's several different methods to do that. On the screen, you can see a variety of different methods for absorbing noise and sound. All of them come with their varied degree of results that they can achieve, but they all have one thing in common other than resilient absorbers is that they're significantly more expensive. And so what you see is where cork rubber lives as is a resilient absorber, you have the largest potential for reduction, while you also have the lowest cost for that reduction. So real quickly, we've talked a couple of times about Cork and why Cork potentially for this type of application, and Cork has many features that make it a special raw material. But the couple that really come into play for this application are the impermeability to liquids and gases, its elasticity and compressibility, and its acoustic performance. These are the three main features of the cork that we're able to lean on in this application. Um, so as we speak about cork and rubber in a vibration control application, what are those main advantages that we can offer versus some of the other materials? Well, one, we have proven uh, noise and vibration solutions working with OEMs throughout the world and have long-term performance with those units and that partnerships. We offer the chemical resistance needed, whether it be mineral oil or ester oil, synthetic and natural, or silicone oil. So we're able to accommodate any of those fluids. We guarantee noise reduction, and you will experience longer machine life and tooling life with extended maintenance periods. That we know. And you'll also get our dedicated engineering team, Marta, who's with us, to help with any type of support you need with inside the application. And one of the other things that cork rubber lends itself to is being a very customizable solution. So we have lots of flexibility. Part of our offer is internal vibration pads submerged or inside the unit within the oil, external vibration pads, core clamping, decoupling, and compressed layer damper. And we also have some fastener isolation accessories. One thing that we know now that we've talked about the disturbing frequency and where the source of the noise comes from in power transformers, now that we know that, we can talk about what the transmissibility and how the material can perform in the application. So on this graph on the screen, you can see the short humps at the far left of the graph represent the natural frequency of our material, and the graph itself is showing the disturbing frequency of the sound. So you have 40 hertz, 80 hertz, 120 hertz. So let's focus on 120 hertz on the graph. You can see that 120 hertz, which is the double of the 60 hertz that we were talking about earlier, that's the disturbing frequency of 120 hertz. You can see how far away that 120 hertz is from the natural frequency of the material. So clearly, right there, you know that you're going to be isolating and not causing an amplification because you're well past the material's natural frequency. That's the first thing you can notice from this graph. The second thing you can notice from this graph is the large degree of transmissibility that is reduced in the three different thicknesses of our material. The three different color lines represent 10 millimeters thickness, 30 millimeters, and 50 millimeters thickness of material. And you can see that you get a significant performance even at the 10 millimeters in thickness. And there's a huge gain in performance when you add another 20 millimeters in thickness. But then when you add another 20 millimeters in thickness, there is a smaller gain. So what this shows and demonstrates is that there is a sweet spot for how thick the material is, for the performance that you'll get from it, and also that you can go thicker and thicker, but the performance gains once you get past 30, 35 millimeters are start to become much smaller. So one thing that's important to note is the shape factor of a cork rubber material, and it's important in the comparison between rubber and cork rubber. While rubbers are incompressible, so when you compress them, they have to squeeze, they have to flow, and you have to accommodate for that. Cork rubber does not displace near as much volume because cork can compress on itself. So this lower Poisson ratio allows for a wider shape factor tolerance. And what that really means is it gives us a very flexible and robustness of design. So we can customize the shape of the pads in a lot of different sizes, whereas a rubber material doesn't have that degree of customization. So within our noise and vibration control lineup of materials, we have three main grades of material that we feature. We have our VC 1047, which is for external applications, but typically not outdoor. So external outside the transformer, but can be used inside buildings, inside different types of enclosures, that type of thing. The VC 2100 material is the oil immersed vibration control material. It's meant to be used inside the transformer, submerged in oil. Also can be used for sealing oil, but its the main use is to be used inside the transformer as a vibration pad. And then the VC 6400, it's an external vibration control material meant for outdoor applications. So it has ozone and UV inhibitors added to the formulation to make it robust and hold up in outdoor applications. So Amorim has it developed a four-step approach to treating noisy equipment, and we do that with the use of internal pads, core clamping, external pads, and then our CLD or compressed layer damper. So these are our four ways that we can approach noisy equipment. So here in this diagram that you'll see, we have a picture of a transformer and we have our four-step solutions listed. And you can see the first solution is an internal vibration pad. It goes underneath the active part, underneath the core that's doing a lot of the vibration. But we also need to do the number two step, which is the core clamp mechanism at the top of the transformer. The two of these to go together, and when you put the two together, you can expect to see anywhere from 3 to 5 dB in reduction. These two applications take a very minimal amount of any engineering design to accommodate, and are very easy for OEMs to adapt. We say that you need to do both of them because this is the core that is being decoupled from inside the bottom of the tank. And if you don't decouple it from the top of the tank, there's a pathway for the vibration to migrate to. And so if you do both, we typically recommend you do both at the same time. You can experience 3 to 5 dBs reduction. Now, the CLD is our third step in the process. This is where we are stiffening the wall, and I'll speak about that in a second. But again, it's cumulative, so it's not 6 to 8 dBs just using the CLD. It's using the internal, using the core clamping, and then using the CLD. It's cumulative to 8 dBs. And then if you're able to utilize the external vibration pads, which are pads that go underneath the footprint of the transformer, outside of the transformer, those accumulative, again, if you use all four, can go to 10 dB and sometimes even higher. But what I will say about all four of these steps is that if you were to use just one of them, you're typically going to see anywhere from 1 to 3 dBs in reduction. So even just using the external vibration pads, which take zero engineering on the customer side. We just need a small amount of input on our side, and we can help to create the custom solution. The pad can get you 1 to 3 dB reduction just by putting the transformer on top of some pads. So that alone is the easiest and the most uninvasive way to get some reduction right away. And if you're able to use number 4 with the external pads and combine it with number 1 and number 2, which again take very little engineering, you can cumulatively get somewhere between 5 and 7 dBs reduction really easily with those three versions of the application, and it's not very costly either. So I think a couple of those parts of that application are very clear. The pad underneath the core, the pad underneath the entire transformer. I think those are very clear. The core decoupling, I wanted to spend 1 more minute on and show you some imagery. It's really just a way to decouple the top of the core to where you're connecting it to the tank. So it's fairly straightforward, but you want to use some type of methodology like this so that you have the complete decoupling of the core from the top of the tank. And then I wanted to also spend 1 minute speaking specifically about the CLD. This is a really, really fascinating part of this application. It gives us really, really good results. And part of it is the application is lining the inside wall of the tank of the transformer with with the cork rubber and a small additional layer of steel to put it under compression. And it's under when the material is under compression that it does a lot of its work. So we know that the sound can come off the walls of the tank, and of course you can stiffen them by just making the steel thicker, and of course just by adding this other small layer of steel to do the compression, we are adding some steel and stiffening the wall of the tank in that method. But the main reason why this works so well is because the cork is under a small amount of compression, and it dissipates these sound waves into the shear force in between the compression of the cork rubber material between the two walls. So yes, we are stiffening the walls a little bit in a way, but we are also dampening a large amount of the sound waves in shear forces. And so this is a really exciting part of the application. It does take a little bit more engineering work on the customer side to place the bolts in the place and to cover the tank wall on the inside. But the customers that do use this application continue to feature it on their units as they go forward. So real quickly, we have a couple of case studies just to kind of highlight some of the results that we've gotten with some of these applications. The first one is our VC6400 exterior controlled. These are pads that were put on the bottom of a transformer outside the transformer. The target by the customer was a 3 dB reduction, and the end unit ended up with a 5 dB reduction. So an exceptional result, exceeded the customer's expectation by 2 dB. These also, ozone was an issue, so the VC6400 was a perfect solution. Another case study that I'd like to feature is the internal vibration control material, our VC2100. In this particular case was a reactor, uh, large reactor unit. We had pad dimensions, 30 millimeters thick by 230 by 230. And the pads were placed to decouple the tank wall, the reactor from the tank wall, and again, achieved exceptional results with 5 dB reduction. And the last case study I'd like to feature today is again our VC2100, but this is to demonstrate some of the flexibility. This is a large noise reduction in a distribution transformer, so this is something that was really exciting for us. We have decouple inside the unit, but also decoupled at the top of the tank. And again, we're seeing a 3.9 dBA reduction. Again, an excellent result for us in this application. And so now, with having had a chance to discuss the application a little bit, I'm going to turn it over to my colleague, Marta Reinas, to share a little bit of the story of our sustainable natural material cork.
Yes, thank you, Chris. And before starting, I would like to remember that you can put all your questions and doubts in our chat, that we will answer to them after we finalize this presentation. So now talking a little bit about the sustainability of cork. Cork is a 100% natural material, and it's very versatile. It is able to have very good CO2 retention that we will see in some minutes. But before starting, I would like, for the ones that are not familiar with cork, I would like to explain a little bit about it, that cork is the outer bark of the cork tree, meaning when we extract the cork from the tree, we are not killing the tree, we are only peeling the tree, sorry. This is a natural process, and we are able to make the first extraction after 25 years. And after this period, every 9 years, we are able to extract it again. Besides that, it is really interesting that this type of trees have an average life expectancy of around 200 years. Also, in the past years, we have made some sustainability tests to see how cork is able to retain and sequester CO2. And regarding some studies that we have performed, we were able to get to the following result. 1 ton of cork produced is able to retain up to 70 tons of CO2. These are very amazing results. And based on this study, we were also able to perform some case studies to our material, meaning and taking in consideration our VC2100 and considering 1 square meter at 30 millimeter thickness, the amount of cork present in this material is able to sequester up to 560 kilograms of CO2. These are very amazing results. Besides the vibration control applications that Chris has mentioned during this webinar, Amorim Composites also have applications such as gaskets for sealing different parts of the tank, and also repushing condensers. It is also important to say that our T&D materials are free from asbestos, heavy metals, and polyaromatic hydrocarbons. Talking here a little bit about our company for you to be aware about ACC. So, Amorim Cork Composites research and develops and manufactures sustainable and high-performance cork composites for many applications and industries, not only for power industry and sealing, but also for other areas such as footwear, mobility, and energy. Amorim Cork Composites belongs to Corticeira Amorim, that has a worldwide presence, as you can see in this map. Inside of Amorim Cork Composites, we have at the innovation department our iCork factory, where we have the goal to develop new products, new applications, also new technologies always to support markets needs and also to make some adjustments to fulfill the requirements to the market. We are able to adjust formulation, create new materials, or even a mix with other materials in order to enlarge the performance of our solutions. And to finalize our presentation, ACC is certified against the typical norms and certifications of these industries and these markets, as for an example, the ISO 9001 and others related with energy management, health and safety management, along with quality and environmental management systems. At this moment, I would like to thank you for your attendance on this webinar, and we are open to answer to all your questions, so feel free to ask in our chat. So we have a first question that I will make. It is expected that there is some heat retention inside the transformer due to the cork insulation, especially in the CLD case. So to answer to this question, cork is a natural thermal insulator, but it will not heat too much when it's used in CLD or even in vibration control. It will not impact the performance and will not retain the heat there. So it's not, it will not create any issues of overheating or that kind of situations. So don't worry with this case.
Great question. Very good question.
The second question that we have, what is the main advantage of the cork rubber gaskets versus the rubber gaskets for sealing the transformer? So here we are in a topic that we haven't approached in this webinar, that are the gaskets and the sealing solutions. But generally speaking, our material is able to have better compressibility and also adjustability to the flange, meaning this type of transformer, it's very used to have some connections or even some deformations or even some painting points that needs to be minimized, and our material in this case is very able to conform to the flange and minimize this topic. If you are interested to learn a little bit more about our sealing solutions, please send us an email that we can make you a detailed presentation about it, or even also make a training session especially for you to explain and talk a little bit about the sealing solutions. Third questions related with external vibration control is 14 millimeters enough thick for the external vibration pads, or we should recommend thicker? So in this case, the thickness is very dependent also on the weight and of the transformer and the space that we have available. Because when we do the dimensions of the pads that are needed to be applied on the transformer to have this reduction, we need to be aware about it to make the right dimensions. Sometimes, and most of the times, 30 to 40 millimeter thickness is our best thickness solutions. In other cases, we might need to go to 35 millimeters or something like that. But in this case, 30 to 40 millimeter thickness is the typical thickness that we recommend to external vibration pads. Another question that appears is the calculation formula for the external vibration pads the same for the dry and oil transformers? Yes, it is the same. What is mandatory to have to make this calculation is mostly the weight of the total transformer, or the weight that will be applied on the top of the vibration pads, and also the footprint of the transformer. If it is, let's say, a flat surface, or if we have some footprints, because we need to be aware about this area. Otherwise, it is equal to have or to make this simulation to dry and oil transformers. And another question that we have here is, what is the compression ratio of Cork, particularly the one used underside of the core oil assembly pads? So for our VCs, we recommend a compressibility around mostly 25%, around it. It depends also a little bit because we have a range, but typically is around 25%. That's why we need to be aware about the space and the weight that we have on the transformer, because when we do these calculations, we need to guarantee that is inside of the stress range. Regarding the CLD application, in this case, it's a little bit different. For the CLD application, we recommend that the material it's around 10% compressed. Here we are talking about the solution, our cork and rubber, our VC solutions. I don't know if I was clear on these topics and if you have more questions, but we still have a little bit of time. So if something on my explanation was not clear or other questions appear, feel free to ask. In addition, I would also like to remember afterwards, even if you have other questions that appear, you also are able to make this type of questions through our commercial team, or even through our website, where we have a contact request. You can fulfill it, that we will also answer to that.
Okay, well, I think we've got we had some great questions there at the end of the session. Really insightful questions that we've encountered before. So I've really appreciated the people who asked questions. Thank you very much. And I'd also like to say thank you to each and every one of you who took the time to attend today. We were happy to be here to present to you, and we were even happier that you took the time to join us. So from the team at Amorim Cork Composites, we thank you, and we look forward to your vibration control servicing your vibration control needs in the future. So thank you, everyone.
Thank you. Have a nice day.